Welcome back to the Arduino Masterclass. In this episode, we're diving deep into one of the most fundamental parts of Arduino coding, variables. Whether you're a beginner or just brushing up, today you'll learn every major variable type used in Arduino with simple examples and real project tips. So, what is a variable? A variable is a way to store data in your Arduino sketch. Think of it like a box with a label. That box can store numbers, text, or even true/false values. You can use that label to call the value whenever you need it. And here is the basic format for defining a variable in Arduino. So in the first, we have the variable type. Might be an integer, a float, a double, a long, char, and so on. Then the variable name, so we give a name to that variable and the value which it will store. It could be a number, or if the type is char, it could be a character, it could be a true/false value if the type is Boolean, and so on. So let's start with the integer. So when I say int, I mean integer. An integer is simply a whole number, no decimal points, just number like -5, 0, 42, or 1000. Or it could be a negative number like 9000, and so on. On Arduino UNO, which uses an Atmega 328P microcontroller, an integer takes up to 2 bytes of memory. That means it can store values from -32,768 to 32,767. Now, for example, int lead pin equals to 13, or int temperature equals to -5, or int counter equals to 1000. Here lead pin is 13, temperature is -5, and counter is 1000. All whole numbers, no fractions. But what if I try something like this? The Arduino will actually cut off the decimal part and just store 10. That's something to keep in mind. Integers don't round, they just drop the decimal. So whenever I only need whole numbers, like counting steps in a loop, storing a pin number, or keeping track of button presses, I use integer. On that note comes float. A float is used when I want to store numbers with decimals, like 3.14 or 2.56. Or it could be a negative number as well, like 34.25. So if I print pi, I'll get this number. But if I try something else, like 1, 2, 3, 4, 5, 6, 7.81, it might lose accuracy after the 6th or 7th digit. So the float is super important when I'm dealing with sensors. For example, a temperature sensor might give me 23.78, and I definitely need a float to keep those decimals. If I stored it as an int, I'd lose all the accuracy. And now here is where things get interesting. Double. In many programming languages, a double has twice the precision of a float. But on an Arduino UNO, double is actually treated the same as float. Both are 4 bytes, both have about 6-7 digits of precision. So if I write double pi equals to 3.14 and the rest of the pi number, I might expect more precision, but in reality, the Arduino UNO still cuts it at around 6 and 7 digits. But if I move to more powerful boards like the Arduino Duo or some ESP32 boards, double is actually 8 bytes and gives me about 15 to 16 digits of precision. So that's where double becomes useful. And now let's move on to two other very important variable types, char and boolean. First, let's talk about char. So char stands for character. It's used to store a single character like a letter, a number, or even a symbol. In Arduino, a char uses 1 byte of memory, which means it can hold values from -128 to 127 if we treat it as a number, but usually I use it for characters. So here is a simple example. Char letter equals to a semicolon, and that's it. Notice that I wrote the letter A inside single quotes, not double quotes. That's important because double quotes are for strings, while single quotes are for a single character. So if I want to print this out, it will just simply show an A on the serial monitor. Yeah, but here's the interesting part. Every character also has an ASCII value. So let me write here as a comment, every character has a ASCII value. What does it mean? So every letter has a number value in equal. So for example, the letter A actually represents the number 65 in the ASCII table. So if I do this, add this det on serial print, it will print 65 instead of A, but it's a bit fast. Let me just add a delay here. Yeah, so as you can notice, it prints 65. This is useful when you want to work with characters as numbers. Moreover, you can codificate the letters into numbers, so no one understands what's written there. Now let's look at Boolean. So Boolean is much simpler. It can only hold true or false. Internally, true is stored as number 1 and false is stored as 0. So true 1 and false 0. Oops. Booleans are super useful when you're working with logic, like turning lets on or off or checking if a button is pressed. So let's try it with an example. Boolean let state true. Delete this. And now let's connect an LED to the Arduino to the pin 9. The other leg, of course, to the ground. And in the code, the void loop function, I write if, oops, caps lock, I forgot the caps lock on. Let state is true, then digital, right, 9 high. So let's state is true, send the code, and as you can see, the LED turns on just a little bit. That's because I forgot to define the pin mode on the void setup function. So 9 output. Now send again the code. And yeah, as you can see, the LED turns on. And if I set the LED state to false, the LED would stay off. So to sum up, char stores a single character or symbol, and it can also be used as a small integer. with ASCII value, and the Boolean stores only true and false, perfect for logical decisions. And that's it for this video, guys. I tried to explain shortly actually most of the variables of Arduino. If you found this video helpful, please put a like down there. Thanks for watching and see you in the next one.